That's the tool released yesterday, and yeah, working on a new one. Working on a new one. It's on the same topic around EEG. Oh, I think I closed that example. I forgot to add it to my project. EEG. We had the ECG signal as well. E signal. We wanted. Yes, this example was more comprehensive than what we currently have. Wait, was it? No, that's the one we implemented. There was something else to it that we were trying to implement. So now this is the one of the older tools. Yeah, it will show ads in here to use an ad blocker. So first, if you make the window smaller, the ad will disappear. But yes, I'm just using ad blocker in Firefox. So these are the two new tools. I just posted a video about this one as well. This one needs more work to update it some more. Yeah, instead of number of samples, this has to be time. I can add noise onto the BPM. Ba, 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 ba. This will add noise onto the amplitude of the peaks. Anyway, I need to update this user interface, also make it more friendly on a smaller screen. Currently, it will do funny things. Don't know how small is a mobile screen. Yeah, I need to split all this up. So that's the front end. That's what's generating the HTML. JavaScript should be in another file. Yeah, I can't do text based development. It's hopeless. HE. So yeah, this tool will need more work as well. Hopefully someone can provide feedback on it before I make any more changes that no one wants. By the way, this is a bit of a bug, the fact that it keeps refreshing the screen. It's meant to actually do it only once. Yep, it's kind of bug that is also a feature. And to update this overview here, ECG generator. This was the old EEG generator. Probably remove it eventually. This is the front end calling the API. And by the way, anyone can call it as well. It's just available on the same domain, also on bionichaos.com, just a different port number. And in this case, which one is it? Yeah, the EEG generator. You will have your raw EEG output and the spectrum in a different frequency band. The delta T, delta F, I don't know in this case. Those are odd numbers, I have to correct them. With the back end is was originally taken from a LabVIEW example, and who had to change it quite a bit. It probably needs more work. Yeah, it's a bit messy, but it's been there since like 2013 or something. We're looking at another example of EEG. What was it? Find examples. Search. Is it the EEG? No. No, it was. Actually, it was an ECG. Yeah, HRV analyzer. So yeah, again, one of those very old examples. So I have that's the source code, and this is extracting features already. Yeah, but the main reason I was looking at it is this point Curie. It's a French name. I don't know how to pronounce it. A graph, which is handy for ECG analysis. One of the things I'm trying to do is make those tools mobile friendly. So depending on your screen size, but I don't know what you're using it on. If you use it on a tablet, it might be a screen about this size. Or a mobile, I think it will display like this, but then you would see. Yeah, I don't know what you would see. Depends on the size. Have to check all the options. Ideally, it should just scale automatically, but it's hard to get it right. And I'm using an ad blocker. But on another screen, you will also have an ad at the bottom or top. I think on the mobile phone, it's on the top, and on a larger screen, it will be on the bottom. And that's when you know you're in trouble. This is calling a C function. So let me know what should I focus on first. Point Curie curve, which is supposed to indicate so it's correlation between peak in ECG distance. Yeah, this x and y axis should be the same. It's essentially a sliding window of all the. There's a good explanation. Should put a link to it. I had it open yesterday. Yeah, there's an explanation here. I don't know how to pronounce his name, but essentially, it's a distance between QRS peaks. That's a real good explanation for it. It's this software. Right, so it's essentially if you overlay. Right, that's actually would be a better thing to do is to a graphical overlay of all QRS complexes. Yeah, now it starts playing as well. I was just saying there's a bug to this one that I already spent too much time trying to fix. Kind of gave up on it. But essentially, when you scroll through these things, it keeps sending commands to the API server, get requests. So if you just click on it once, it works okay. There's no major delay. But if I keep scrolling a bit, then there would be a delay before it will start auto scrolling again. Colors actually mean are they correlated to what's on the correlation plot? And yeah, I'm really bad at reading things. I need to see it. I don't understand what's the. Just looking at the graph alone, it's like find the differences or something. If I meant to just go up and down on the, one-to-one line, but apparently not. So curious what this software is. This is an interesting bit where there was a day versus time thing. Is there a chance this is a free software? Highly unlikely. Right, so this is what the atrial fibrillation will look like. To get this. What are the different colors in there? We'll have to dig into it offline. Don't really understand.
This picture can be used to demonstrate revealing noisy areas in the signal. Misinterpreted. Misinterpreted RR intervals. Marking the area of suspicious points and then browsing in the ECG strip shows whether there are ectopies in the signal or a noise due to lead off. Noisy areas can be easily deleted. BTL cardio point, Poincare graph 9. BTL's contribution. Although the Poincare graph has been implemented in many commercial Holter systems, only the BTL cardio point makes it interactive. Any section in the graph can be marked and all events, represented by individual dots, inside the selection can be reviewed and verified. This makes the Poincare graph not only a tool for analyzing patients' HRV, but also a tool for detecting rhythm disorders and potential noisy areas. Word procedure example 1. From the very first look, the Poincare graph looks sus biased as there are more clusters. Furthermore, these clusters are positioned behind the 2000 milliseconds range. This may indicate pauses, but also noise, falsely diagnosed pauses. Hence it is recommended to review the ECG strips corresponding to the dots inside these clusters. Marking the clusters and using the navigation buttons, next beat, previous beat, first beat, now allows to reveal and browse through all the events in the ECG strip window. Any falsely detected pause can be easily removed from the diagnostics using the delete button. BTL cardio point, Poincare graph 10. Word procedure example 2. In a healthy person, the graph
What? Why would you delete stuff?
In a BTL, marking the clusters and using the navigation buttons, next beat, previous beat, first beat, now allows to reveal and browse through all the events in the ECG strip window. Any falsely detected pause can be easily removed from the diagnostics using the delete button. BTL cardio point, Poincare graph 10. Word procedure example 2. In a healthy person, the graph other should stay empty since any dot in this graph may correspond to an ectopy. In this example, the graph is full of dots that furthermore form a pattern typical for premature beats. Moreover, the red color indicates ventricular beats. It is hence recommended to explore the corresponding ECG signal. Marking an area of interest is again the first step. Now instead of browsing the ECG strip, pressing the / button on keyboard will open a graphical split tool. The graphical split tool displays all the heartbeats based on the selection made in the Poincare graph one behind each other. Hence, an instant and clear look at all the SE-lect beats is provided and all morphologies can now be easily compared. In this example, it is possible to see that polytopic, having different shapes, premature ventricular beats are present in the signal. BTL cardio point, Poincare graph 11.
I don't know, is this a textbook stuff? I need some textbook stuff. Do they have references? No. Yeah. Let's check out. A Scholar. It's actually interesting. I think someone was, I don't remember who was mentioning it, like doing EEG, essentially image processing. Yeah, you can do it too. So is this a standard thing to do? So essentially calculating 4 metrics in an angle, width, and then sliding direction, sliding bar. Sliding bar. How old is this paper? It's like been printed on paper. 2015. What is the different delta? What different metrics are there? Yeah, just trying to figure out what's standard. They're jumping to neural networks for no particular reason. It's an engineering journal, is it? This is a bizarre graph. This essentially means that it's all like saturated. If you have that level of performance. Yeah, it's like the neural net must be way too good. But it's fine that they're zooming in on that section. It's not. I don't think it's very useful. Unless, well, yes, in this case, it will be to know what's Comet Torpedo. What are these names? But there's the difference between it will be like 90% to like 99%. True positive, right? And what's this fan thing that's perfect performance? Just use that. Yeah, the DSL as well as performing essentially 100%. It's really weird, chat. There's something more realistic. This p value, look at this. Ah, okay. It's perfect. Problem solved. What's amazing about all this? Yeah. I just trying to understand the overall system. Anyway, I'm just trying to figure out the standard way of plotting this thing in the first place. This done in Levy looks suspiciously similar. It must be Levy. Because even the colors and everything is the same. Let the Levy. Right. That's handy. Date of this. Oh, 2018. How did they exported it into something? And where's the actual data? The data from the example? No. But this is a handy paper with the reference to it. Right. Arduino engineering heavy, is it? Yeah, that's the same plot as this one, but where do they... a handy paper as well. The graphs are just all over the place. Also 18 as well. That's the data from. They recorded it or something of themselves or whatever. Those changed the way tool looks. That way around. As they jump from the QRS complex. Make this figure to KDCG amplifier whole board. Then Levy doing something. It's just showing all the Levy code, just publish it as a code. Processing program. Oh, come on. And that's from 2 to 3 years ago. It's the code published. All the color display, okay. Download a figure. We need this R diagram. The original example just had SD1, SD2. They added some other measurements. I don't know what they are. This is the number of points. The histogram. I hope they publish the code. Don't tell me there's no code. I'll reference all these papers, but let me know if you're more interested in EG or ECG. I should, in theory, know more about EG. That's been what I've been working for in a while. ECG is a new thing for me. Where's the right here? This thing had to add a file that actually has seizures in it. These are not seizures. This is just a noisy channel there. Also trying to make it more mobile friendly. And I'm looking at those correlation plots for ECG. We'll try turn them into a web application. Have to turn it into an API first. And not sure which data set this one is using. It's obviously an actual recording. To edit. Wait. Then add it to my Panic Chaos project. Copy. Oh, I think once we turn it into a web app, it really doesn't like spaces. So add it into this analyzer. What was the original one? Now let's see what this tab's actually showing the waveform. I want to see the waveform, don't we? Get the not used to be a big fan of these tabs, but not so much anymore. No, first of all, they're not very web VI friendly. Just this what's the original signal is. Would be taking out just random. Just one graph. Wait, are those? Now I'm confused. KRS. So this a multi-array of all these things. That's interesting. That's only taking the R and substituting it from the previous value. That's a shift register. So it's essentially taking the current R minus the previous R. Skeleton, no. What is it called? Graph palette, yes. I mean, so the first there should be 0. It's not 0. I also have a scroller. Right, so this is the distances between current and previous R. Oh, come on. I'll just leave it as is. Just move it to. I was actually, because I was interested in this will be separate QRS. It's a bunch, more than 2000 of these arrays with the onset, offset, ISO level. This noise is not high enough, I think, but meant to vary the distance between the QRS peaks, R peaks. So how would that affect this graph? MSG feature array. So why isn't it not the same? Where's the data from?